So this lesson is about motion with constant acceleration. So there are a set of formulae we can use to describe motion with constant acceleration, which we call the SUVAT formulae. So the first thing we need to do is define all our variables. So we know that S is displacement, U is initial velocity, V is final velocity, A acceleration, and T time. And at the moment, we're only going to consider motion in one dimension, so along a straight line. So the most important thing to remember about these formulae is that they can only be used when acceleration is constant. And you need to learn these. You need to learn all of them, and you need to have them quick and ready to use as soon as you see any question that has constant acceleration. You also need to know how to derive these, and I'm going to go through the different ways that we can derive these formulae. So first we need to look at acceleration being the gradient of velocity. So if I have a velocity time graph and I've got constant acceleration, that's going to be a straight line. And I know that acceleration is going to be the gradient of that graph. So if I have an initial velocity u and a final velocity v, then I know that the gradient is going to be the difference in that, so v minus u divided by t. So I get that a is equal to v minus u over t, and then I can rearrange that to give me my SUVAT equation. The other way I can derive that SUVAT equation is by using integration. So I know that velocity is the integral of acceleration with respect to time. So I can apply that, and I also know that the initial velocity is u. So when t equals 0, my velocity is u. So that's going to be my integration constant. Then again, I just need to rearrange my equation to get the final formulae. We can also use the velocity time graph to look at displacement. So we know that displacement is the area between the velocity graph and the time axis, and we can calculate the area of that using the formula for the area of a trapezium. So we have a half of a plus b times the height, where a and b are our two parallel sides of the trapezium. So in this case, our a and b are our velocities. And then we just substitute that in, and we end up with one of our formulae for constant acceleration. Now we can use those two that we've derived to derive the others. So the first thing I'm going to do is I'm going to eliminate t from equation 1 and equation 2. So I'm going to rearrange equation 1. So I end up with v minus u equals at, and then t equals v minus u over a. And then I can substitute in that expression for t into my equation number 2. So I do that, and I can rearrange, and I end up with another one of my formulae for SUVAT formulas. Carrying on in the same way, I can eliminate v, so the final velocity, from 1 and 2. So I just substitute in my expression for v from equation 1 into number 2 and rearrange, and I end up with another one of my SUVAT formulae. The other way we could come up with that particular formula is by looking at the integral of velocity. So we know that displacement is the integral of velocity. So I can apply that, and then I know that at the initial time the displacement will be 0. So my constant of integration will be 0. Finally, we can eliminate the initial velocity from 1 and 2, so the exact same method, and substitute that in, and we arrive at the final formula. There are so many other ways that you can derive these formulae using elimination and calculus, but these are just a few of the ones, and you need to know how to derive them. So when we're answering questions using the SUVAT formula, there's a few things we need to do. We need to make sure that we select the formula based on the information that's actually given to us in the question. So what I recommend you do is write down exactly what's given to you in the question and then put a question mark by whichever variable you need to find. And then you can use that to select the formula that you actually need. So let's look at this example. So the first thing that I'm going to do is I'm going to write out all the variables that I've been given. So my acceleration, I know it's deceleration, so it's going to be negative acceleration, my initial velocity, my displacement, and I want to find the velocity, the final velocity. So I put v is equal to a question mark. Then I can use that to decide which formula I want to use. So I want to use v squared equals u squared plus 2as because that includes all of the variables that I have on the left-hand side. Then I just need to substitute in and rearrange to get my final answer. I do the exact same method for b, so I need to write down everything that I know on the left-hand side and then put a question mark by the variable that I actually want. So I want t, so I need to put a question mark by that variable. Then I can use that information to decide which formula I need to use, and then I just substitute in. I end up with this quadratic in time. So I can need to use a calculator. I can use a calculator to solve that, or I could use a quadratic formula, but I can just use my fancy calculator, and that gives me the final answer. Let's look at the second example. So once again, I'm going to write down all my variables on the left. So I've been given the displacement, so I write that down. I've been given the initial velocity, I've been given the time, and I want to find the final velocity. So I write the final velocity with a question mark. And then I can use that to select the formula that I actually want to use. So I know that s equals a half u plus v times t contains all of those variables. So that's the formula that I want. Then I just plug my values in, rearrange, and that gives me my final answer. In this next example, we can use the exact same method. So I'm going to write out all the information that I know. I know the displacement, I know the initial and the final velocity, and I want to find the acceleration. So I know I want to use the formula that contains those variables. So I need to use v squared equals u squared plus 2as. Then I can rearrange that to get a on one side. Then I can plug in my values and I end up with this negative acceleration. If I look back to the question, it's asked for deceleration, so I know that the deceleration is the positive version of that acceleration. In this final example, I need to use the exact same method. So I'm going to write down all my variables on the left. So I know that the displacement is 25. I know she's accelerating at 0.9. And I know that she reaches the bus stop 4 seconds later. I want to find the velocity, so I write v equals question mark. So I know the formula I'm going to use is s equals vt minus a half at squared. So I can rearrange that to get v equals, and then I just plug in my numbers and end up with my final answer. So have a go at the classroom work. It's on OneNote with all of these examples, and let me know if you have any questions.